Hello my dear children, welcome to the mathematics class. Today we are going to discuss permutations and combinations. In this chapter we are going to discuss the problems in the exercise 7.1, page number 138 in the textbook. In the previous class we have discussed the concepts of exercise 7.1, that is fundamental principle of counting. We have discussed the fundamental principle of counting. There are two types, namely counting principle of multiplication and addition. Okay, my children, according to the question, we use the fundamental principle of counting. Most of the cases we use fundamental principle of multiplication. Okay, my children, right. Come to the question number 3. Yesterday we have completed 2 questions so far in this exercise. Now come to the question number 3. How many 4-letter code can be formed using the first 10 letters of English alphabet if no letter can be repeated? Understood this question, my children? Which kind of letter code? Yes, 4-letter code. In that code, 4 letters should be there. By using first 10 letters. Okay, my children, how many letters are there in our hand? 10 letters. Okay, my children. So, let us take number of 4-letter. Here repetition is not allowed. No letter can be repeated. Okay, my children. So number of 4-letter code is equal to number of ways of filling the 4 blanks as shown below. By 10 letters, by the first 10 letters of English alphabet. If no letter can be repeated. Okay, my children. So let us take the 4 blanks. In that code, how many letters are required? 4-letter code. So we have taken 4 blanks, 4 empty boxes. It means we have to perform 4 events, one after the another. Isn't it or not, my children? Right. This is the first event, this is the second event, this is third event, this is the fourth event. Filling the first blank is considered as first event. Filling the second blank is considered as second event. Filling the third blank is considered as third event. Filling the fourth blank is considered as a fourth event. So let us take this first blank. Yet no letter is repeated. How many letters are there in our hand? 10 letters. So the first blank can be filled by how many letters? 10 letters. Isn't it or not, my children? We can fill that first blank by any one of the 10 letters. Understood this first blank, my children? Right. Into, because we have to do all these events one after the other. So fundamental principle of multiplication, here we use that concept. After one letter is filled by this blank is filled by one letter. How many letters will be there in our hand? Only 9 letters. So this blank can be filled by any one of the 9 letters. Yes or no, my children? Right. After filling this second blank, how many letters will be there in our hand? 2 letters are already filled by these 2 blanks. In these 2 blanks. So 8 letters are there in our hand. Yes or no, my children? Yes. So this third blank can be filled by any one of the 8 letters. Yes or no, my children? Right. And means into. Okay, my children. How many letters will be left in our hand after filling the 3 letters in these 3 boxes? Out of 10, 7 letters will be there in our hand. So the last blank can be filled by any one of the 7 letters. 7 ways are there. Yes or no, my children? Yes. So this is the required number of 4-letter codes. Okay, my children. Multiply 90 into 80, 720. 720 into 7. So we can write 5040 4-letter codes by using the first 10 letters of English alphabet. Understood this question, my children? Right. Now come to the next question, that is question number 4. How many 5-digit telephone numbers can be constructed using the digits 0 to 9 if each number starts with 67 and no digit appears more than once? Understood this question, my children? Here we have to write 5-digit telephone numbers. Which digits should be used? 0 to 9. Okay, my children? And that 5-digit telephone number should be started with 67. And this is another condition. No repetition. No digit appears more than once. Means no repetition. Repetition is not allowed. Okay, my children? Right. Come to the solution part. Digits to be used to construct 5-digit telephone numbers. Which digits are to be used to write 5-digit telephone numbers 0 to 9? So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, my children? These are the digits to be used to write 5-digit telephone numbers. Okay, my children? Now let us take 5-digit telephone numbers which are starting with 67. Out of 5 digits, how many digits are given already? 2 digits are already given. How many digits should be required? 3 more digits. Yes or no, my children? Yes. So let us find out the number of 5-digit telephone numbers starting with 67. Okay, my children? Number of 5-digit telephone numbers starts with 67 and no digit appears more than once. Is equal to. Okay, my children? Here logical thinking is very important for this chapter, my children. Already 2 digits filled in the 5-digit telephone numbers. 2 digits already given, fixed. 3 more letters, 3 more numbers are required. Isn't it or not, my children? So number of is equal to number of ways of filling the 3 blanks as shown below. as shown below by which numbers should be used here. Already 6, 7 already used. No digit should be repeated, means these two numbers should not be used again. Okay, but it's learned. By which digits? By 0, 1, 2, 3, 4, 5, 8, 9. Yes or no, my children? We have to fill the remaining 3 blanks. Already 2 digits fixed. We have to fill the remaining 3 digits by these digits only. Understood this point, my children? 3, 2, 3, 4, 5. Okay, my children. In this 5-digit number, this 5-digit number is starting with 67. How many blanks are there? 3 blanks. 3 more blanks to be filled. By which digits? These digits only. Again, we should not use 6 and 7. Understood this point, my children? Right. So, let us take this first blank. Means here 3 events are there. 3 operations should be done, one after the another. After one operation is completed, we have to complete the second operation. After second operation is completed, we have to complete the third operation. Okay, my children. Automatically here we have to use fundamental principle of multiplication. Okay, my children. Right. So, first blank. This blank can be filled by any one of these digits. Yes or no, my children? Yes. 1, 2, 3, 4, 5, 6, 7, 8. So, out of these 8 digits, we can fill this blank by any one of these 8 digits. Okay, my children? Into. Now, to come to the second event. This second event, the second operation can be done by remaining 7 letters. Already one letter is fixed. One number is taken here. One number is filled in this blank. So, how many digits will be there in our hand? Only 7 digits will be there in our hand. So, this is second operation. This is second blank can be filled by any one of the 7 digits. It can be done by 7 ways. Understood this 7, my children? So, this operation is also finished, completed. This event also completed. After that, third event. How many letters should be there in our hand after filling these 6 letters? Yes or no, my children? So, we can fill this last blank by the remaining 6 letters in 6 ways. Yes or no, my children? So, we have to find 8 into 7 into 6. Okay, my children? That is equal to 8 into 7 into 6. Multiply. 8 sevens are 56. 56 into 6. 336. So, we can write 336 5-digit telephone numbers. We can construct 5-digit telephone numbers which are starting with 67 by using the digits from 0 to 9 with no digit appears more than once. Understood this point, my children? Understood these steps? Right. Here in this chapter, logical thinking is very, very important. Formulas are less formulas. Very few formulas are there. But logical thinking is highly needed. Okay, my children? Right. Now come to the next question, that is question number 5. A coin is tossed 3 times and outcomes are recorded. How many possible outcomes are there? Okay, my children, understood this question? Right. Now let us find the possible outcomes if a coin is tossed. Okay, my children? Possible outcomes when a coin is tossed. If a coin is tossed, what are the possibilities? Either head or tail. head or tail. For our convenient, I wrote H. H stands for head and T stands for tail. Okay, my dear children, only two possibilities. But here a coin is tossed 3 times. How many times coin is tossed? 3 times. Then we have to find number of possible outcomes. Okay, my dear children. So, number of possible outcomes when a coin is tossed 3 times is equal to number of ways of filling the blanks given below by H or T. Okay, my children. So, let us consider this is first time, this is second time, and this is third time. How many possibilities if a coin is tossed here, either head or tail? Okay, my children. So, 2 possibilities. Second time, if a coin is tossed, how many possibilities outcomes? Here also 2. Here, either head or tail. Third time also, either head or tail. So, how many ways? So, 8. So, totally 8 outcomes we will get. When a coin is tossed 3 times, we will get 8 outcomes. Okay, my dear children. Now, I will write the list of these 8 outcomes. Okay, my dear children, what are the 8 outcomes? See here. First time, head or tail. First time. Okay, my dear children. First time, here I am writing the list of outcomes because number of times is a less number. Here I am writing the list of outcomes. First time, either head or tail. Yes or no, my children? Right. Second time, first head, second also we can get head, or first head, second time tail. Yes or no, my children? Or first tail, next time head, or first time tail, second time also tail. If a coin is tossed 2 times, we get these 4 outcomes: H, HT, TH, TT. Yes or no, my children? Can you find more than these 4 outcomes? No, only these 4 outcomes. Okay, my children, only these 4 possible outcomes. Now come to the third time. Then what will you get? 3 times heads, or first 2 times head, third time tail. Yes or no, my children? Otherwise, first head, tail, third time head, or head, tail, or tail. Yes or no, my children? Similarly, here, tail, head, or tail, first time, second time head, and third time tail, or first time tail, second time tail, and third time head, or first time tail, second time tail, and third time also tail. So total how many possible outcomes? 1, 2, 3, 4, 5, 6, 7, 8. We got it this point, my children. Since the number of times coin tossed is a less number, I wrote the list. If it is a big number, it is not possible to write this list. Understood this point, my children? Please remember this table also. If a coin is tossed, only two possibilities, either head or tail. If a coin is tossed two times, only four possible outcomes: head, 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 tail, tail, head, or tail, tail. If a coin is tossed three times, then head, 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 tail, head, tail, head, head, tail, tail, or tail, head, head, tail, head, tail, 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 head, and three times tail. Okay, my children, do you remember this table also? Right. Otherwise, sometimes they will give two coins are tossed simultaneously. If two coins are tossed simultaneously, then also possible outcomes. If three coins are tossed simultaneously, if three coins, here one coin is tossed three times, otherwise if three coins are tossed simultaneously, then also these only 8 possible outcomes. Understood this point, my children? Right. Now come to the next question, that is question number 5. Sorry, question number 6. Question number 6. How many, see, given 5 flags of different colors, how many different signals can be generated if each signal requires the use of 2 flags, one below the other? Understood this question, my children? How many different colored flags are there? 5. Okay, my children. So number of, come to the solution part. Number of flags of different colors. That is 5 different colored flags are there. In a signal, how many different colors should be required? 2 flags, 2 different colored flags should be required, one below the other. Okay, my children? Right. So, number of different signals can be generated if each signal requires the use of 2 flags, one below the other, one below the other, is equal to, we are finding the number of flags of different color, number of different signals. Okay, my children, is equal to number of ways of filling the 2 blanks by 5 flags of different colors. Okay, my children, as shown below. See here, let us consider this is a signal. Here one different color, one color, and the second one is different from this first color. So this first, in this signal, 2 flags should be there. Here in this blank, how many flags can be filled? Any one of these 5 flags. Yes or no, my children? Here also 2 events are there. Choosing the first flag. After choosing the first flag, we have to choose the second flag, which is different from first flag. Okay, my children, understood this point. So In how many ways can we choose first flag? 5 ways, because only 5 flags of different colors. Understood this point, my children? This event is done. This job is over. This operation is completed. Now second operation, that is second event. Second event means second flag, choosing the second flag of different from this color. How many ways are there? 4 ways. Yes or no, my children? After choosing this one flag, we have to choose the remaining 4 flags, any one of the 4 flags. So 4 ways. So these 2 events, these 2 operations can be performed one after the other. Okay, my children, understood? So 5 into 4, that is equal to 5 into 4. So 20 different signals can be generated. 20 different signals can be generated. Understood, my dear children? Right. In this chapter, logical thinking is very important, my dear children. Formulas are very few, very less. Okay, my dear children, remember this point. Without logical thinking, you can't solve the problems. Here, steps are also very few steps. Okay, my children, understood? Right.